So this is the first of the short answer questions within the paper set. We've had the 10 multiple choice questions. And this question, to be honest, is a bit of a stretch for me for GCSE to be able to answer it without having been specifically taught about it for the purposes of this, because this comes up a lot at A level. Do it in mechanics and mathematics, and we do it in A level physics as well. A lot of the stuff required to be able to answer this does come up at GCSE, but never put together quite in this way. This is a standard object on an inclined plane question, which you would get at A level, so it's good preparation for A level. But I do think that quite a number of GCSE candidates would probably put some fairly sensible stuff, but not get very many of the 5 marks. So what you need to realise, and stuff you've done about, is the forces acting on this. So this will be the weight, which is mg. Now the block doesn't fall into, so if we manage, this is what we call limiting, so the angle's at limiting friction, so it's not quite sliding down the slope, it's just not sliding down the slope, if that makes sense. There has to be a force upwards, otherwise this force would mean that the block accelerates through or into the slope. And if you put a block on a slope, it doesn't fall into the slope. So there must be a force pushing upwards, and this is called a normal reaction force, and it acts at 90 degrees to the surface. The actual size of that arrow should exactly match this length. I haven't quite drawn it to scale, but it should exactly match this length. So the component of this force in this plane, the plane perpendicular to the slope. And that's something you might have heard from the vectors. And we can draw a vector triangle here and just do it using trigonometry and Pythagoras in the same way you would treat a geometric triangle of physical lengths. You can do it with vectors and forces and any other vectors like velocities or accelerations. So we have this, we can call that the normal reaction force, NR. And then if these two forces are acting and it's not sliding down the slope, then if you look at these cannot cancel each other out because they are not collinear. They're not in the same direction. Yeah, they're not parallel or anti-parallel to each other. They're not acting along the same line. So there must actually be another force acting up the slope. And that other force acting up the slope is the frictional force. And that must exactly match this so that we do not get any acceleration down the slope. That force is actually proportional to the normal reaction force, and it depends on something called coefficient of friction. And at limiting, that will be exactly equal to this length acting up the plane. So the vectors all work. So you've got a frictional force acting there, so I'll call that friction there. So you've got all those forces acting. Now, as we increase the angle, the friction, as you increase the angle, the normal reaction force reduces. So we get less and less grip. And if you imagine standing on this slope and being tipped up and up and up and up, you'd slip down, and that wouldn't surprise you. But that's because your normal reaction force is reducing, and therefore the frictional force reduces. So then we're looking for 5 marks worth of content to explain that. So to get the marks, you need to say that the frictional force depends on the normal force. Then you might say, as the angle increases, the normal force decreases. Therefore, the frictional force decreases. That would mean that the component of weight, so this weight component that we talked about acting down the slope, component of weight causes the block to slide down the slope. And then finally, this happens when the force down the slope exceeds friction. Again, straightforward question, I think, once we're into year 12. but a difficult question for a GCSE student.